Linear equations, changing from equations to tables. What is the template for a linear equation? A linear equation is typically written in the form y equals mx plus b, where m represents the slope of the line, and b represents the y-intercept or the starting point. In this video, we'll be looking at linear equations and writing a table, and then we'll go backwards where we look at the table and write a linear equation. Problem 1. Here we have the equation y equals 3 over 2x minus 5. Looking at the equation, which part refers to the slope? Locating x, the coefficient in front of x is 3 over 2. That's going to represent our slope. Let's go ahead and break down the slope even further. Which part represents the change in y? The number on top of the ratio, this 3, that represents the change in y. And the number on the bottom of the ratio, the 2, that represents the change in x. Now, which part of the linear equation represents our y-intercept? Notice that we have this 5 by itself, so you might think our starting point is 5, but we have to be careful. Here we have a minus sign, so our y-intercept is actually going to be at negative 5. Now, with all this information, we can go ahead and make a table. Starting at 0, we know that we have a starting point or a y-intercept at negative 5, so that's the first point in the table. Using our change in y, we know that each y value is going to be increasing by plus 3. So moving down the table is going to be plus 3. And taking a look at our change in x, we know that's going to be plus 2. So as we move down the row, we know we're adding plus 2 each time. So filling out our table, our next row, moving 2 down, we'll be at the point 2. And then adding plus 3 more, negative 5 plus 3, that's going to be negative 2. So our next point's at 2, negative 2. Continuing the pattern, we know that x is going to be plus 2. So 2 plus 2 is going to be 4. And then taking a look at our y's, adding plus 3 more, negative 2 plus 3 will be at 1. So our next point's at 4, 1. And finally our last point, we know that x is being added plus 2. So now we're at 6. And looking at our y's, 1 plus 3, that's going to be 4. So our last point's at 6, 4. So using the parts from the equation, we're able to generate a table. Problem 2. We have the equation y equals negative 4x plus 7. Looking at the equation, which part refers to our slope? Locating our x, we know that the coefficient in front of x is going to be our slope. So we have a slope of negative 4. But let's break down the slope into its two components. What's the change in y going to be? The change in y is going to be negative 4. And now let's go ahead and try to figure out what the change in x is going to be. Notice that this does not have a denominator. So when we don't have a denominator, we can treat this as over 1. Because negative 4 divided by 1 is still negative 4. Taking a look back at our equation, which term represents our y-intercept? Notice that this plus 7 by itself, this is going to be our y-intercept. Now that we analyzed our equation, let's go ahead and make a table. Starting at 0, what's our y-intercept going to be? We're starting at 7, so 0, 7. Taking a look at our y values, we know our change in y is going to be negative 4. So as we move down the row, we're going to be subtracting 4. And taking a look at our change in x, we know that's going to be plus 1. So as we move down, we're going to be adding 1 each time. So now let's go and complete our table. Plus 1 for our x, so our next row is going to be 1. And then minus 4, 7 minus 4, we're going to be at 3. So our next point is going to be at 1, 3. Moving forward, another plus 1, so we're now at 2. And 3 minus 4 is going to be at negative 1. So our next point's at 2, negative 1. So continuing the pattern one last time. Plus 1 for x, we'll be at 3. And looking at the y's, negative 1 and 4 more negatives, we'll be at negative 5. So the last point should be at 3, negative 5. Problem 3. Here we're going backwards. We're starting with a table, and we're going to try to figure out what our equation is going to look like. So let's start off with finding our y-intercept. Our y-intercept is always going to be at 0. So notice that at 0, we're starting at 12. So in our equation, we're going to be starting at plus 12. Now let's go ahead and figure out what the change in y is going to be. As I move down each row, how are my y values changing? How do I get from 12 to 8? We know that 12 minus 4 is 8, 8 minus 4 is 4, and 4 minus 4 is 0. So it looks like our change in y is 4. Where's the change in y going to go in our slope? The change in y is going to go on top of our ratio, so negative 4 goes on top. Now let's take a look at our change in x. How are the x values changing? So going from 3 to 0, that's plus 3. 3 to 6 is another plus 3. And from 6 to 9, that's plus 3. So our change in x is 3, and that's going to go on the bottom of our ratio. Now that we have all our components, we know that the equation for this table is going to be y equals negative 4 over 3x plus 12. Problem 4. Given this table, let's try to figure out what the linear equation is going to look like. Here it looks like we're not starting with our y-intercept, so let's try to figure out what our change in y is going to be first. Comparing from one row to the next, how do I get from 5 to 11? 5 plus 6 equals 11. And now that 11 plus 6 is going to be 17, so it looks like our change in y is 6. Taking a look at our x, how do I get from one row to the next? How do I get from 1 to 4? That's going to be a change of plus 3. And from 4 to 7, that's also going to be a change of plus 3. So, how do we write our slope? What goes on top of our ratio? We know that change in y goes on top, so we're going to have 6 on top. And our change in x is going to go on the bottom, so we have 3 on the denominator. Now let's see if we can use our slope to go backwards. How much of a jump does it take to get from 0 to 1? That's going to be a jump of plus 1. So I'm not taking a full jump, I'm taking a third of a jump. How much of a jump is that going to be for my y? If I'm making a third of a jump here, a third of 6, 6 divided by 3, this is going to be a jump of plus 2. Now that we have our jump, let's try to figure out what our starting point is going to be. What y-intercept, if I add plus 2 to it, is going to bring me to 5. The answer to this is going to be, our y-intercept is going to be 3. Because you know that 3 plus 2 is going to bring us up to 5. So we have a starting point at plus 3. So to wrap up, let's make sure these slopes are constant. Here at this row, we have a slope of 2 over 1. 2 over 1. And our original slope was supposed to be 6 over 3. Are these the same slope? If I divide the numerator by 3 and divide by 3, I can see that 6 divided by 3 is 2, and 3 divided by 3 is 1. So when I reduce this fraction, it turns out that this is the same slope. Going from an equation to the table, looking for our slope that's in front of x, that's going to tell us what our change in y and our change in x are going to be. And looking at the constant by itself is going to tell us our y-intercept or a starting point.